Critics of renewable energy technologies argue that too many issues stand in the way for them to power a modern economy. Storage is cited as a key problem yet to be solved.
Hold on.
At Australian National University, one solution is about to be commercialised. Dr. Keith Lovegrove has found a way to capture and store the sun's energy through a thermochemical reaction.
What we're actually doing is dissociating ammonia. We're splitting ammonia into its constituents of hydrogen and nitrogen, and this is our method of storing solar energy so that we can build power stations that work 24 hours a day.
Sunlight is reflected from mirrors onto a concentrator. Small pipes carry ammonia through the concentrator, where the sun's heat separates it into hydrogen and nitrogen. These chemicals store the sun's energy until it is needed. The chemicals are then brought back together when required, producing enough energy to run a turbine and create electricity as needed. 10 new solar concentrators are being built in Australia, but innovations in solar storage could have far-reaching applications.
We have more sun per square metre of continent than any other continent on the planet. And maybe what we want to be thinking is the potential of our country to be the place where the solar energy is collected. And there's a very intriguing possibility there with solar thermal systems that we can use concentrators like this to drive chemical reactions and generate renewable fuels that we can export to other countries. We can power Japan from solar energy collected in Australia's arid areas.
Another obstacle for renewable energy is whether the conventional electricity distribution system, or grid, can accommodate it.
What we have here is Australia's first plug-in hybrid electric vehicle. All set, ready to go.
Chris Dunstan leads a project called the Intelligent Grid. He and Josh Usher are using the first plug-in, plug-out hybrid car in Australia to demonstrate one method of using and storing renewable energy. Electricity is plugged in from a standard household power point and stored in the car's batteries.
314 volts.
It has a socket to charge up the vehicle. It also has another socket to run power back to charge appliances or equipment, or potentially to feed back to the grid at times of high demand. When we look at it in the context of transport fuels, the cost of providing electricity to move this car to travel around works out at about a quarter the cost of providing petrol.
This hybrid car also functions as a mobile battery of sorts. Beyond their application in the automotive industry, these cars can store energy to feed back into the larger electricity grid. Renewable energy that can be supplied through sources such as solar thermal.
You could supply, again, over 90% of the transportation sector from solar thermal electric power plants sitting on the grid. And so basically the two largest single emitters in the largest emitting country can be taken out by the same technology. It's a very powerful result.
This approach shows how many new forms of renewable energy can be brought together in a complementary fashion.
So when we bring those elements together of the larger solar thermal plants and geothermal plants, complemented with smart metering and small-scale distributed energy like photovoltaic panels on our roofs, that will provide, I think, the sort of framework within which we'll see the sustainable energy becoming the dominant form of energy supply to meet the needs of tomorrow's economy.
Could this be an industrial revolution for the 21st century that includes nature as part of its thinking and design?
These different technologies are in a sense a bit like plants in a garden. They will need to sit in relation to each other so that they work harmoniously. So this is sort of thinking about all the way we design things and the way that we work as an ecology, not as a machine.
Tapping nature's energy resources in innovative ways, these world-leading scientists are on the brink of redesigning our future. The question remains, will the public embrace these technologies in time to make a real difference?
But unless people know what's possible, we won't get there. Can we power the transport sector from electricity here? Can we power the entire stationary generation sector from electricity here? Can we do it with these technologies or these plus a few others? I think we can. And I think it's looking good.